Hi everybody, it's Hazel and welcome back to another ACE Explains video. Welcome back to ACE Tutoring Solutions. Today we're going to be talking about the measures of central tendency and how to solve for mean, median, and mode. Now in elementary school, when you were taught this, you were usually taught mean, median, mode with range, but we're actually going to be covering range in a different video where we talk about the measures of dispersion of which range is a part. We're also going to be talking about how to graph mean, median, and mode on a normal distribution or bell curve. This is extremely important because in many statistics questions, and this is like an easy test question, it's like a no-brainer. Professors don't even have to think about it, but they can just ask you like, oh, where does mean, median, and mean fall on a normal distribution curve, or which measure of central tendency might best represent the data. So this is, like I said, easy test question, so we want to prepare you for that. Okay. Let's get started. So there are, of course, we talked about the three measures of central tendency, the starting one being mean. And the mean is just the average of all the values in a data set. Right? My S looks a little wonky. Oh well. So all the values in a data set make up the mean. Excuse me. All the values in a data set make up the mean, or the average, as some might call it. And in order to solve for the mean, you take the sum of all the values and you divide it by the number of values, right? So you take all the values in the data set, add them all together, and then divide that by the number of numbers that occur in the data set. And this gives you the average or the mean. Now, in STETS, there are two types of means. There is the population mean, and the sample mean, It is important to note the difference between these two means because, remember, in statistics, there's two different types of statistical reasoning. We can be solving for a population, or we could be solving for the statistics of a population, or we could be solving for the statistics of a sample. Remember that the correct term used to describe statistics when referring to a population is parameter, while when referring to a sample, the correct term is actually statistics. So we make this distinction with the mean as well, because we could be solving for the average of an entire population or just the average of a sample of that population. Now, there are two common symbols that you'll see for mean when you are being asked about it on tests, and also you'll see them on the calculator as well. That's why it's very important to know these symbols. The population mean is written like this, and this is the microgram symbol, if you remember from chemistry, if you've taken chemistry. And the sample mean is represented with an X bar. It looks like this. It's an X with a bar on top. Very original. So these are the symbols for population and sample mean. All right, so let's try some problems together, talking about mean here. The following data represents the travel times in minutes to work for all 7 employees of a startup web develop company. So we know that there's 7 employees in total, so the total amount of values is 7. That's very helpful because that will be the denominator of our fraction. These are the values in the data set, and then they ask us to find the population mean of the data and then take a simple random sample of 3 employees and compute the sample mean. They also ask us to do a second one, but we probably won't have time for that, so we'll just do one. All right, so 7 employees. Basically what we do is we add all of these values together, and then we divide that sum by 7. So here I am drawing in my little plus signs. We're going to add all of these values together. Now, You can do this in your head. Don't know why you'd want to. We're just going to use the calculator here. So I'm just putting all my digits into the calculator one by one and putting plus signs between them. You get the gist. Adding them all together, and I got 174. 174 divided by 7, because there's 7 employees, 7 values, and I got 24.857 or 24.86. 25, you could round until the cows come home. So yeah, that would be the population mean of the data. And then after that, it asks us to take a simple random sample. So now we're going to find the sample mean. So we could find a simple random sample by literally just going eeny, meeny, miny, mo and picking 3 numbers. So that's what I'm going to do. I'm going to pick 18, 43, and 36, just for kicks and giggles. So we have 18, 43, and 36. There's only 3 values in this sample, so when we add, we're going to be dividing the sum that we get by 3. So 18 plus 40 plus 36 is equal to 97, and 97 divided by 3 is equal to 32.33 repeating. So that is population and sample mean. All right. Not too much that's like difficult there. The next thing that we have to do is the median. So median is when you find the middle term in a set of values. The middle term in a set of values is known as the median. Sometimes there is not always a focused middle term because there's an even number of values, and for that you take the average of the 2 middle values that you find. So if you have an even number of values, you take the average of the middle 2. For example, if you had 1, 2, 3, 4, 2 and 3 are the numbers in the middle, so you would add 2 and 3 together and then divide by 2 to get 2.5, and that would be your median. Now, you're lucky if you have an odd number, because then you don't have to do this. The median is usually represented by a capital M for median, so that's not too bad. And then you have the mode, which is the value in the data set that has the highest frequency. The highest frequency. Basically, the number that occurs in a value or in a data set the most amount of times. And sometimes there can be more than one mode. That's what's unique about mode. There can only be one mean and one median, but there can be multiple modes. There can also be no mode, but there will always be a median and there will always be a mean. So that's also really important as well. Just a little trivia for you. Okay, using the same numbers from the mean question, let's find our median and our mode. So to find the median, we need to first put all the numbers in order. So I order the numbers from lowest to greatest. So I start with 5, then I have 18, then I have 23, then 23, then 26, then 36, and then 43. And then I slowly count off the numbers from either end until I close in on the middle. 43, 5, 36, 18, 26, 23, and our median is 23. Same thing, if we want to find our mode, now we don't have to put our values in numerical order to find the mode. We just have to look for the number with the highest frequency, or the number that occurs the most. So for this value set, it looks to be 23. So the mode is 23. Not too challenging, super simple. All right. Now, it's also really important to talk about, I want to remember to talk about resistance. Resistance is super duper important when we're talking about measures of central tendency, and I know this because I got this question right on a test and nobody else did. This is a trick question that tricks up many statistics students because they have no clue what resistance even means. So what resistance means is that if you were to add an extreme outlier to a data set, the measure of central tendency would not be severely affected. Right? So, a crazy high or a crazy low outlier that is super outside of the range of data should not have a large effect on a measure of central tendency. If it does, then that measure is not resistant. Okay? Resistant means that crazy high outlier, no effect. But if there is an effect, then that measure of central tendency is not resistant. That is super duper important because it tripped up like adults in my stats class. I wanted to make sure I mentioned that. So the two measures of central tendency that are resistant are median and mode. These values are resistant. As opposed to that, mean or average is not resistant. And that is always the answer, no matter what the data set has in it, right? Median and mode are resistant measures. Mean is a non-resistant measure. The last thing we want to talk about when we talk about mean, median, and mode is about the distribution curve. So we always want to talk about where these values would be placed on a distribution curve. So when we're talking about a curve that's skewed left, we see that mode is always the highest value on any curve, whether it's normal distribution, skewed right, or skewed left. Mode is always highest every single time. Well, it's not always highest. In right skewed, it's the other way around. But the peak of the curve is always highest because that's where the most amount of numbers occur. So in a skewed left graph, mode is greater than the median, which is greater than the mean or the average. And in a skewed right graph, it is the opposite. The mode is less than the median, which is less than the mean, right? Basically, the mean is always located where the skew line is. So in a left skewed graph, the skew line is toward the left, and the mean is where the skew line is. The median is in the middle, and then the mode is at the peak of the distribution curve. And on a right skewed graph, the mean is toward the skew line. On the right, the median is in the middle, and then the mode is where the peak of the graph is. That being said, if a statistics question asks you what is the best measure for any curve, no matter what type of curve it is, always say median. Always say median. The median is the closest measure to the true data because it's in the center in every single graph. In a normal distribution graph, the mean, median, and the mode should be about the same number. That's what tells you if a set of values is normally distributed. If you test the mean, the median, and the mode of a set of numbers and they seem to be around the same number, then you can confidently say that that graph is a graph with a normal distribution. There's another tip for you if they ask you a question like that. All right. Thank you guys so much for watching this video. Make sure to tune in to other statistics videos by clicking our playlist down below. As always, if you have questions, put them in the comments and someone from our team will try to answer it. And make sure to watch our other statistics videos. I think I said that. But also to watch our other videos because we have videos on lots of other topics. See you guys next time. Bye-bye.